Can everybody see the presentation? Okay, so now let's get started. And during the presentation, if any one of you had some problems or questions about the robotic arm or the information I mentioned in the presentation, just feel free to chat. Okay, we will see your comments and feedback, and we can answer you some of the questions in the Q&A section. Okay, let's get started. So our topic today is get to know more about robotic arms. And this is relatively related to the theoretical knowledge training of intelligent manufacturing robots. So let's get started. Nowadays, with the fast development of the AI, collaborative robots are beginning to appear in the public, such as factory assembly line, in the manufacturing line, and also as a vending machine in the street. We can also see some robots, such as the vegetable greenhouses, independent picking equipment, and also the mobile cell combined with inspection equipment. Because of the robot's safety and efficiency, collaborative robots are rapidly entering the intelligent manufacturing market. Today, I will share the content of the collaborative robots. So we are going to break it down into 7 chapters. The development of the robots, the main components, the working principles, and some external sensors. Also, we'd like to share some applications market of the robotic arm. And we also look into the future. So in the 6th chapter, there is a future trends of robotic arm. And finally, we'll show you some of our star products, which is the myCobot series products here. So let's begin. Let's look at the development history of the robotic arms. So with the progress of development of human society, more science and technology culture is displayed in front of the people. In order to solve the problem of travel, people invented cars, trains, solar energy, nuclear energy, and some traffic tools. And in order to solve the energy problem, people invented wind energy, solar energy, nuclear energy, and tidal energy, and other power tools. And here we had come to another problem, which is the rising labor costs. So people invented robots. Since the emergence of robots, we have introduced the concept of robots in all walks of life. Up to now, robots have been involved in many areas, such as the industrial area, medical, social, and automatic driving areas. So what is the definition of robot? What exactly is a robot? Let's look at the definition. So robot is defined as a programmable actuator that has a certain degree of autonomy and can move in its environment to perform some tasks. According to the IFR classification standards, robots can be divided into 2 series. One is industrial robot and another one is service robot. So industrial robot refers to the robot that is applied to the production process and the environment. And other service robots refer to all kinds of robots that are used for non-manufacturing industries and also that are used to serve human beings. Some common service robots include personal service robots, household service robot, and professional service robot. And here we are in China now, so that's a little bit different in China's robot industry. The Chinese Society of Electronics classify robot into 3 categories, which is the industrial robots, service robot, and special robots. So according to with the event of the robot era, everyone has different views of the robot. And maybe many of you have some questions about the robot. How do they work? Like, are they dangerous? Are they stealing our jobs? Especially, we have mentioned that many robots are used in the manufacturing line that are used to hire labor, human labor. And will the robots replace humans? How can we use them? And what can they do for us? How do robots interact with people? With these questions, let's learn about the robot development. So I'm going to talk about the history of collaborative robots. So in 1950, the devil first proposed the concept of industrial robot, and they applied for a patent. In 1959, the first industrial robot was created in the United States, and in the 1980s, the industrial robots were further developed and play a very important role in this era. In 1982, General Motors of the United States equipped robots with a vision system on the assembly line. So that's the perceptual robots invented. So perceptual robots have external sensors, which we will talk about later. And the offline programming can be carried out with the support of the sensing system with different degrees of environmental perception and self-correction programming functions. And then we have divided the evolution of collaborative robots into 3 stages. The first one is the laboratory stage, which is from 1950s to 1980s. And the second stage is the embryonic stage, which is from 1970s to 1990s. So that's when the medical service robot and the entertainment robot came into the public. And the third stage is now, which is called the development stage. The fast development of the computer and the internet and the human-robot interaction. With these development, service robots are now widely used in many applications. You may have seen some service robot on the street and in the restaurants delivering food. That's the service robots. So we have talked about the definition of a robot and the categories of the robots. Now we will talk about the main components of a robotic arm. What composes of a robotic arm? Now, first one is the hardware. In this picture, we can see there are 2 kinds of robots, which is the industrial robots on the top and the collaborative robots on the bottom. These 2 kinds of industrial robots, their hardware composition are similar. They are composed of 3 parts. The first one is robot's body. The second one is the electric control box. And the third one is the demonstrator. So in terms of the robot's body, let's look at the industrial robots here. They are composed of 3 components as well. The first one is the core drive unit. The second one is the structure of the robot. And also because the robots needs to be powered, so it needs electrical cables and connectors. We can see from the picture there are 2 kinds of industrial robots, which is the vertical multi-joint robot and the SCARA robot. And here we want to talk about more about the structure of the robot. So we can also see all the manipulator, all the robotic arms are made of connecting rods. This is the rod, and the rods can be connected by joints. And these joints are usually equipped with position sensors that measure the relative position of adjacent links. The position of the revolution joint is called joint angles. So in fact, this rod is the main. So I mentioned before, the main rod, the joint is the mechanical structure of the body. And the joint also is the core transmission component. And if we look at the collaborative robots, the structure is relatively similar with that of the industrial robot. They are composed of core drive units, structure of robots, and also with electrical cables and connectors. But here, there is a little bit difference. We are going to talk about the core drive unit or the core transmission units, which is the precision reducer and a servo motor. So we can see in the picture here, there is a reducer, and inside a motor box, there is a servo motor. That's how the robots can move. And let's now talk about the precision reducer. There are two kinds of precision reducer, the harmony reducer and RV reducer. So why do we need to use the speed reducer? Have you think about these questions before? As we know, the servo motor speed is very high. In this case, the torque is very small. So how do we improve the torque? The answer is to slow down the motor. So we are going to use a speed reducer. Now, the harmonic reducer is mainly composed of three parts: the wave generator, the flexible gear, and also the steel wheel. Now, in this picture, in this video, you can see the speed of the inside circle is relatively high, but in the harmony reducer, the speed of the outside circle will be slowed down. So that's how we use the harmony reducer to slow down the speed. And we can also see there is another kind of speed reducer, which is RV reducer. This reducer is more complex, so we are not going to talk about this RV reducer. We just need to know that precision reducer's function or its purpose is to reduce the speed. And that's how we can improve the torque of the body of the robot. Besides, we can also look at the servo motor. So this is another very important core transmission component. The commonly used motor is servo motor. We can see that there are two types of the servo motor: AC servo motor or DC servo motor. And how does a servo motor work? When the servo motor receives a pulse, it will rotate. It will rotate at a corresponding angle. And the servo motor itself has the function of sending pulses. So it receives pulses, and it can also send pulses. When it rotates, when the servo motor rotates at an angle, it will also send a corresponding pulse, and the pulse will contacted by the servo motor will form echo or a closed loop. So the system now knows how many pulses are sent to the servo motor and how many pulses received from the servo motor. So that in this system, it can control the rotation of the motor to achieve very accurate positioning. And the positioning accuracy can be up to 0.01 millimeter. So now let's talk about some mechanical structure of the robot. We can see there are three parts: the mechanical principle and constitution. We have mentioned it before. Did you remember that we have mentioned the rods and the joints? That's the mechanical structure of the robot. And the common mechanical design, there are two types. which is the finite element analysis or the modal vibration analysis. So in this part, we are going to give you a little brief introduction, but we are not going to go into detail. So if you have any problems or any questions about this part, this mechanical design, you can pop up your questions in the chat room, and we will answer you after this section in the Q&A section. In the third part, it is the machining technology. And the common machining technology includes CNC and the casting. Likewise, these two machining technologies is very important, but we are not going to do a very detailed instruction because of the limitation of the time. So we only need to know, in order to understand the mechanical structure of the robot, you need to understand what is a mechanical principle and constitution, and the mechanical design, and also the machining technology. Last one, the third one, is the electrical cables and connectors. So the cable used in robots are mainly the internal flexible cable, and we also have a connector to make every cable connected together. So we have talked about the structure of a robotic arm. So how do we move a robotic arm? In what direction and at what speed? The answer is the software. So we will talk about the working principle of the robotic arm. So in this figure, you can see the software architecture of the robotic arm. It has several very important factors. If you look at the control box here, we have three important factors: the position, the speed, and the current. So we can understand that the robots moves to the corresponding position according to corresponding speed, right? Yeah. You want to move it to this position in a very high speed or very low speed. That's what we can control, right? How do we control? So here we have the current adjustment. The current is to use to calculate the driving force of the droid. So combined with these factors, we can carry out kinematic modelings. So we had the core algorithm here, the kinematic algorithm module and the dynamic algorithm module. Again, because we are not going to talk too much about the algorithm, we have listed the core function, the core algorithm here, so you can have a screenshot if you are interested. So you can look up to the online materials, or we can also provide some materials according to these algorithms later. Okay, so now we have two algorithm modules here, but how can we judge that if the technical indicator is good or not? We have two key factors. The first one is the jitter time of the real-time kernel. And the real-time kernel system of the time should be less than 20 microseconds. And the second one is the fast motion trajectory accuracy. So the core algorithms are listed here, and we will provide the link later if you can see our chat room. These are the robot controlling functions. So we can see there are a lot, and it is impossible to talk too much in detail of every core algorithm functions. So that will leave to you for further development, further expandation. Okay. So we have talked about the structure of a robotic arm, And we have also talked about the hardware and software of a robotic arm. We are now going to talk about some external sensing devices. So why do we need the external sensors, and why how they are used in the robotic arm? So although the safety of the collaborated robotic is higher than the safety of the traditional industrial robotic arm, it is still impossible to complete complex work by only relying on the robotic arm itself. In order to solve this problem, the human-robot interaction technology has been introduced. So now, what is the human-robot interaction? What does it mean? It refers to the technology of communicating with computer in an effective way by means of computer external hardware equipment. In human-robot interaction, human input relevant signals to the robot through some input devices. That is the sensor, including one or more modes of voice, text, images, force, touch, etc. So after receiving the input signal, the robots provide relevant feedback signal to human through output or display devices. That is the human-robot interaction. So scientists and engineers have introduced a variety of sensors to solve the problem of input signal recognition for robots. But some people may not know what exactly is a sensor. So now let's talk about some definition here first. So sensors are the media for robots to sense the world. They provide the robot the external environment signal. They provide the robot this ability of the sensory organs in human visual perception, force, touch, smell, and taste, and so on. So with these sensors, they allow robots to have the feeling of people. So sensors are just like the eyes, nose, ears of the robot. A sensor in a hardware acts like a receiver of information from the outside world. What are some common sensors for robotic arms? So here are three types of common sensors. The first one is the infrared sensor, and the second one is the TOF sensor, and the final one is 2D cameras. But also there are a lot of sensors used in the robotic arm, but here we are going to talk about these three kinds of common sensors. So the first one is the infrared sensor. Generally speaking, so infrared sensor refers to infrared proximity sensor. Its working principle is to detect the frequency of electromagnetic radiation of the objects. So as long as the temperature of the object is greater than absolute zero, it will emit electromagnetic radiation. So this radiation can be detected. The radiation frequency emitted by human beings belongs to the infrared radiation. So as long as the specific infrared frequency is monitored, the infrared proximity sensor can judge whether the human is near, and that will be very safe if they can sense a human is here. So they can keep a safe distance between human. The second one is the TOF sensor. So have you ever heard of a time of flight sensor used in the cell phone cameras? They are also known as a TOF sensor. It is a measure of the time that an object takes to travel a distance. So it is like the bat sonar system. They are similar. The time-of-flight sensors vary, but the most used one are the time-of-flight cameras and laser scanners. They use a technology called LIDAR, light detection and ranging, to measure the depth of individual points in an image. The data generated and captured using the TOF sensor is very useful because it can be used for pendant strain detection, user authentication based on facial features, environment mapping, use SLAM algorithm, and more. That's the information about the TOF sensor. So the last one is the 2D camera. So I believe that many of you know about the 2D camera. So 2D camera can only obtain a two-dimensional image information. So it has some limitation. When the visual task involves more than two dimensions, for example, it involves the height, the thickness, and the depth, that is the three-dimension change. It is more difficult for the 2D camera to identify this kind of three-dimensional image. So here we had a technology called TM3D vision technology to help users to gain a large extent to make up for the inaccuracy of 2D visual on the visual recognition. So we are not only talking about the sensors, we are talking about the sensors and the technology to combine all the sensors together. So the information obtained by a single sensor is very limited. It can be influenced by the environment and other interference factors. So if the information collected by a single sensor is analyzed in isolation, the internal communication between different sensors will be lost. So that is another technology introduced, which is called multi-sensor information fusion. This technology can effectively solve this problem. So this technology integrated many information for signal processing, bionics, artificial intelligence, and other like theory of mathematical statistics. This kind of information will be distributed in different positions of each single sensor. And then this information can integrate all kinds of information of all the sensors. And this information can be utilized and optimized. So with this multi-sensor information fusion technology, the internal communication between different sensors won't be lost, and that can provide us a lot of useful information. So for example, we have an AI kit, a VR control kit from Elephant Robotics. So in order to make the automatic assembly robot operate in a flexible and accurate environment, many sensors are installed in this robotic arm. For example, visual sensor, laser distance sensor, ultrasonic distance sensor, and force sensor, proximity sensor, and displacement sensors are installed in this robotic arm, which is myCobot of Elephant Robotics. How do they work? Among them, first, the vision sensor is used to identify the objects here. So we can see the object is a block with different colors. So vision sensor can recognize different colors. And it also used to guide the laser distance sensor and ultrasonic distance sensor to get the corresponding position information. So it knows the distance between the arm and the objects. And the processor here in the base, processor will integrate and optimize the information obtained by all kinds of sensors. And the processor will know this precise position information of these objects. And then the information from multiple force sensors, proximity sensors, and displacement sensors on the robotic arm will be integrated. And the processor, again, will analyze the state of the end effectors, which is the Samsung point here on the robotic arm, and determine the safe distance between the robotic arm and the objects. Then it will detect the state information and the contact force when the end effectors of the robotic arm reach the objects according to the output of the force sensor. So all kinds of sensors are used for this VR and AI kit of the myCobot robotic arm. By using all these sensors, this robotic arm can identify the colors and identify the position of the blocks, and it can also determine the force of the Samsung punch to suck the objects and put it into the blanket. So it needs the processor to calculate the safe distance from this position to another position. We had talked a lot of information about the robotic arm now. So how can we use the robotic arm combined with the sensor? Now we are going to talk about the application market of the robotic arm. Can you think about some common application of a robotic arm? Can you type in the chat room? So when we think about the application of a robotic arm, we may probably first think of the palletizer, right? To move an object to another object in the assembly line. So that's one common application market. Here are three I'd like to mention. The first one is the 3C electronic assembly field. That is the application I mentioned before, just to put an object to another, from a position to another position. But in the 3C electronic assembly line, there's a little bit different, because we know that the components of 3C electronics is very small. So it can complete the chip packaging, because we can make the robotic arm, the accuracy very high. So it can put a very small object from one position to another position. We can also use the robotic arm to do other, like chip packaging. Also with the visual system, we can use it as all kinds of sensors and other equipments. So this kind of robot can put small 3C electronic parts, welding installation in place, and also ensure considerable efficiency. Another one is the automated parts assembly field. So the collaborative robots can choose the ways to install different complicated industrial environment. So it can choose the grounds, the hanging, the tilted to install. And so the use of more than one robot can complete some bulky auto parts So we can make several robots work together to complete the automated parts assembly line. Especially, this kind of robot has very excellent precision and very excellent speed. So we can improve the productivity of this part. Last one is scientific research and education. This is also one of the important application fields of collaborative robotic arms. So this mainly because this kind of robot can transfer the operation logic through programming to complete different types of work, which is of great help to students of various majors in industrial robot research. So students under the guidance of the teachers, they can use this robot to create more application and to understand how an robotic arm work. So Elephant Robotics has worked with many suppliers such as NVIDIA, Raspberry Pi, and Arduino to create breakthrough products. We have created compact 6S collaborative robotic arm that deliver high quality performance at very affordable prices. And we also provide a software driver library for deep learning, computer vision, and multimedia and more to help the students to get started quickly. So we have talked about the common application market of the robotic arms. We also look into the future. So what is the future chance of the robotic arm? Think about right now, we are in a COVID-19 epidemic era. So what can we use for robotic arms? If you have any idea, could you please chat in the chat room, and we will see your ideas and thoughts. Your ideas and thoughts might be useful for us and for this industry. The first one is the 5G extended service robot application scenario. So with the emergence of 5G, artificial intelligence and cloud computing, the development of relevant technologies is promoting the evolution of service robot technologies and function, and developing towards more sensitive perception, finer operation of control, and more intelligent human-robot interaction. 5G technology features high speed, right? And low delay and large connection capacity. It can transmit massive data in real time, and it provides network support for real-time application of the service robots and promote robots to complete more complex and more intelligent work. On the one hand, relying on the 5G technology, the relevant data can be quickly transferred to the cloud to provide data support for customer analysis of reception robots and marketing decisions of new retail robots, right? On the other hand, 5G technology enhances the cloud capabilities and provides high speed and stable networks support for the remote diagnosis and treatment of reception robots and remote control of the robotic arm. So 5G enables the transmission of massive data, fast transmission, and enables the support of the cloud computing. That's a lot of things we can do in the future with the robotic arms. Another one is the AI technology. The AI technology boosts the intelligentization of the service robot. So we have some technologies such as the SLAM, the robot vision, the voice interaction, and deep learning as the core, which we can promote the improvement of the intelligent decision-making ability. And some we can also extend the scene coverage of the service robot. The SLAM technology can be used for accurate guidance and positioning, which greatly improve the working efficiency and ensure the safety of a collaborated robotic arms. And using the robot vision technology, collaborative robots can realize the active visual interaction and assist navigation. We had some breakthrough language processing as well. So the deep learning and language communication and emotional communication ability will be significantly improved. So the reception robots, the companion robots, and other future robots can be benefits from AI technology. The final one is the COVID-19 epidemic era. So because of this epidemic, the COVID-19 has deepened of the application of collaborative robots. So how do we use the COVID-19? I mean, COVID-19 is not very good for most of us because it is bad for our health. But in this kind of trends, COVID-19 could be benefit to some industry, right? So we might see some service robot more and more, such as the intelligent guidance, infrared temperature measurement, and identity recognition verification will grow for a long period of time because the COVID. We need to keep social distance. So some works should be replaced with this kind of service collaborated robots. And more, we may have seen more and more delivery robots and reception robots and some new retail robots. That is the future trend of these kind of robotic arms. So at the end of this presentation, I would like to show you some products of elephant robotics. So myCobot series is the first one, the first all-in-one collaborated robot in China, which is launched in 2018. So what does all-in-one mean? So you can think of a laptop right now and a computer back in the 1980s. So in 1980s, a computer should be composed of several components like a screen, a keyboard, a mouse, and a processor, which is very large, right? And here, when we talk about laptop in the 21st century, that's the keyboards and the mouse and the screen and the processor can be put in just one book size device, right? That's all in one mean. And it is the most open source 6S educational robotic arm, which is very affordable. So we had a lot of libraries, materials uploaded online, so people can look into the Gitbook of Elephant Robotics to learn more about the programming, the board, and also the environment, the installation environment of a robotic arm, and most importantly, the algorithm of how to use a robotic arm, right? And these are the open source materials. The third one is that this kind of robot is not only one type. It includes 280, 320, and Pro 600 and other sub-series. So with different working ranges and different payloads from 250 grams to 2000 grams. The core master control is divided into microcontroller and microprocessor. So for most users, I think these myCobot series can meet different demands for the research and commercial display and other functions. Finally, myCobot is suitable for education of science research and commercial application. Just like I mentioned before, we provide hundreds of SDK, we provide ROS development environment, and we provide the full range of development, practical teaching video materials and video tutorials, which you can look up in our YouTube channel. So don't forget to subscribe Elephant Robotics channel, and there are more materials and tutorials uploaded in the future. So we have another new robotic arm here. And I'm going to demonstrate the basic function of teach and jack. Now this one is another one, so this function is successful, and I will demonstrate you one more time. Okay, so if you click the okay, so I will show you how to enter the make control. So here we have the arrow pointed to the make control here, and if we click OK, and it will go in another make control display menu. So here we click play. We click record and click flash, and now we jack the robotic arm to whatever direction we want. After finishing the jacking, we can click save. And now we want to play what we done before. So click play here and click flash. And we can see now the robotic arm is repeated the function, repeated the movement I done before. So that is the simplest way to control your robotic arm with only several clicks of button. In this way, you don't need to know any programming knowledge, and you can make the robotic arm move as you like. This is a starter instruction. And now we will show you how to control the robotic arm using myBlockly. myBlockly is a software developed by Elephant Robotics, and it is based Python syntax. So if you are interested in using Python and myBlockly, that will be a very easy and fun way to control robotic arm. 停一下. So we have the USB connected to the computer. So now if you had connected, we can see the atom here is okay. That means the connection to the PC is successful. So now here, I will again share the myBlockly screen to you. So if we click the red button here, we can use the COM port, and the baud rate is 115200. And we need to, here in this syntax, we also need to make the port number is exactly the same as the tools box here. And now we click open, and we can see it again. Here, it means our connection is successful. If you click autocomplete, and we can see that if your connection is truly successful, then here the parameter should be 0. That means we need to change to another port, which is COM11. And we will connect again. Now this time we can see that the parameters here are not 0. That means this time the connection is truly successful. Now if we click the parameters of the joint, which one do you want to choose? Like joint 1. So if I click here, adjust the joint, we can see the joint 1 is moving according to the parameter. As well, we can control the joint 2. You can also control the joint 3. It will move to with the parameters moving and changing. That's the another basic way to quickly move the robotic arm. And we had also some syntax in this myBlockly to control the robotic arm. So if you click the MDI control, we can see we have many functions here. We had get angle function and we have set angle function. In this one, we can set several angles from joint 1 to joint 6 at a time. So now here, if I put some parameters here, just a minute. And we need to also set the speed to 20 to make sure it won't move too fast and too slow. And we have another function called time function. This is the sleep function. That means how many seconds you want the robotic stay still. So I want it to stay still for 2 seconds. Now we can click run. Now the robotic arm moved to the set angle I just set before. And when the function is completed, we can see there is screen showing that 12 process exited with code 0. That means the function is completed. And now we'd like to show you some other useful syntax, which is the loops. Loops, this is very important function. It's a repeat function. That means how many times you want the robotic repeat the function you had typed below. So you don't need to, like, if I want the robotic to repeat for 5 times. I don't need to type the function for 5 times. I just need a repeat function. So I can also duplicate the function and put it in below. So here I wanted to move back to joint 1 to 0, and I wanted to repeat these 2 functions to 5 times. Now my program is ready, and we can click run. You can see that because I just changed the parameters of angle 1. So this angle 1 will repeat 5 times the movement. After this function is completed, and we can also see the syntax appear again. That means we can now exit this function. So this is 2 simple ways to control myCobot. One is that you can simply drag and record the movement and play the movement using the buttons here. And another one is use the myBlockly. So the myBlockly, in myBlockly you don't need to type too many syntax. You just choose any syntax you want from the modules here and type the parameters you want to set. So that's the basic use of the myBlockly. And if you want to learn Python, you can click Python here. It can automatically transfer the myBlockly syntax to Python syntax. Okay, that's our the end of the demonstration. If you have any questions about controlling a robotic arm using Python, using myBlockly, please feel free to type below, type in the chat room, or you can email us if you have a robotic arm of our products. And we are very happy to provide support, technical support to you. And then let's go to the final part of the Q&A section. So we have some questions in the chat below, and I will answer some questions. The first one's can 280 be operated by battery? Yes, of course we can. The second question is the forward kinetics available? Sure, we have backwards and forward kinetics. These are available for robots. The third one is, can I use my old gripper on your robot arm? So what do you mean? You mean you have a gripper that is not from Elephant Robotic, but you have a robotic arm from Elephant Robotic and you want to connect it together? Yes, that should be okay if the interfaces match. So that will involve a lot of program, and we can also share some ports with you if this is compatible. Okay. The fourth question is, will myCobot support which kind of sensor? So most sensors on the market will work for myCobot, and we can develop their functions by ourselves. So that's a question that similar to the last question, the previous question. So it will involve a lot of programming work, but it will be possible. The fifth question, what's the difference between M5 and Pi? So M5 stack and Pi, which is Raspberry Pi, the difference is that you can see from the appearance, there is a screen of M5 stack, but there is no screen, no button of the Raspberry Pi version. And the systems are also different. The Raspberry Pi mainly supports Linux, Ubuntu system, and the M5 stack version first support Windows, and other systems can also be used, but the priority is not so high. So both versions allow direct programming, but M5 needs to build the environment, but the Pi version does not. It was built inside, so the users don't need to build the environment themselves for the Pi version. Okay, so these are the common questions, and I hope my answers are useful and helpful for you. Okay, Okay, guys, if you have more questions, you can email us at info@elephantrobotics.com. We have some sales workers, colleagues to answer your question, and we want to provide more information online, so you can look up our Gitbook and our GitHub to search for for what you want. We have a lot of materials already uploaded online. Finally, let me share some gift we have prepared for you. So if you can see here, we have prepared several gifts. The first one is the USB flash drive. Here we have prepared this one for you, and we have another shopping bag. We can see the logos of Elephant Robotics, and the products is printed here. That will be very useful and very economic ecosystem, right? It is very friendly to our environment. You don't need plastic bag anymore. So the final one is mouse pad. I believe many of you will use this for work, for programming, or even play computer games that will protect your wrist, right? And we have also printed our products here, and we have a logo in the center of this pad. So how do we win the gifts? How can I get one? Here is the interesting part, right? I'll share the link below. I will share the link. You can fill out. We have a survey, we have a questionnaire for you, because we want to hear what our customer, which is you, what do you think about this robotic arm, and what do you think about the robotic arm, the robot industry, also the robot vision, computer vision. We cherish your feedback. So it will be helpful if you can complete this survey. And I believe that many of you can complete this survey within 1 minute. So it won't take you too much time. Let me share the link with you. Can you guys see it in the chat room? You can also copy the link and paste in the internet address www.jazz. And make sure you leave your email address correct. If you win the gifts, we will contact you by email. So make sure your email address is correct. Okay?